Hi, I'm Amanda Jones, and in this video I'm going to show you how to convert a repeating decimal to a fraction. We all know that if it's a repeating decimal that it is rational, and a rational number can be expressed as a fraction. If the decimal never terminates and never repeats, then it is irrational, so it can't be expressed. These are 8th grade standards, so a little bit beyond the Concepts 1 class that is for elementary majors up through 5th grade. But we always want to be a little bit more knowledgeable and up on our students than what we are teaching. Another thing that this is useful for is that you will have some students, some of you, especially if you're teaching in the higher grades, where you will need to create problems that become repeating decimals. And these can get really messy. So it may be helpful to work backwards and to create division problems with nice repeating decimals. So we're going to take both of these and convert them to a fraction. They are repeating decimals. We're converting them to fractions. Okay. It does take some algebra, and it's probably something that you wouldn't come up with on your own, and that's okay, but hopefully seeing it and seeing the steps, it'll begin to make sense to you, and you'll be able to do it on your own after that. It is a little bit like a proof. So what I'm going to do here is I am going to let x be this value, because I'm going to set up an equation where I solve for x. So I'm going to let x represent that. And then I'm going to multiply both sides of this equation that I just created by the same value to keep it equal. And what I want to do is I want to move this decimal so that I create another decimal that has the same repeating part. So if I were to move this decimal twice, then I would create another decimal that would have the same 5/4 repeating part. So I'm going to do that by multiplying both sides by 100. So I have 100x, and then if I multiply this by 100, it's going to move the decimal twice, and I'm going to have 54.54 worth of 5/4 repeating. Then I can set up an equation where I subtract both of these. If we have two equal equations, then we can subtract them from each other. So I can do this minus this equals this minus this, because these are equal and we can subtract equal parts. So I'm going to do that. 100x minus x, so I'm taking this minus this, is equal to 54.54 repeating minus 0.54 repeating. Well, this repeats for, I'm going to combine like terms now. This repeats forever, and this repeats forever, and forever is equal to forever. So it doesn't matter that this one was, found by taking this one and multiplying by 100. That's way down there at the end of the value that goes on forever. So there is no end. So it doesn't ever happen. You can even see it like that. And so when I combine like terms, once again, 100x minus x, be careful here, it is 99x. And this is going to, the repeating part is just going to drop. It's 54 minus 0 because this is the same. And now we have an equation that we can easily solve for x. In one step, we're going to divide both sides by 99. And then you should always reduce your fractions. So these are both divisible by 9. 54 times is divided by 9 is 6. So I have 6 over 11. Okay. So if you wanted a nice problem for your students to do a division that would become a repeating decimal, and that's great practice for them, do 6 divided by 11. Okay. All right, let's come over here with something similar in that the same kind of part repeating. We have, the 7, 8 is repeating, so 2 digits. But we have a whole number. Now I'm going to handle this very much like I just handled the other. I'm going to drop the 2. I'm going to let x equal 0.78 repeating, and go through the same exact steps. Move the, deal with the 2 at the end, the whole number part at the end. So x equals this. 100x would move the decimal so that I would have the same part repeating. Subtract the 2 equations. Okay, combine like terms. The repeating part drops, and then divide both sides by 99. Okay, they're both divisible by 3, okay? So 78 divided by 3 is 26. I know that because 7 plus 8 is 15, and 15 is divisible by 3. Okay, and then 33 is only divisible by 3 and 11, which neither go into 26, so we know we have reduced completely. But I'm not done, because this is just 0.78 repeating, and I wanted to convert to 0.78 repeating, and so I know that this is equal to 2 and 26/33. Remember that a repeating decimal, you can see it as addition, 2 plus 0.78 repeating. And a mixed number you can see as addition, 2 plus 26/33. And then sometimes we would want this, you know, if we were doing a division problem for our students, we would want this in a improper fraction and not a mixed number. So 2 times 33 is 66, plus the 26 is 92. So we would have 92/33. All right. Let me show you another example when we have something a little different. Okay. So we're going to do 0.16, and the 6 is going to be repeating. All right. So same thing, I'm going to let x be equal to 0.16, no whole number part here. And then I need to create two values by multiplying both sides of the equation by something that have the same repeating part and the same decimal part, okay? So that when I do that subtraction, I'm dealing with whole numbers and not decimals. Now I can just do 10x and get this and do subtraction, and we're still going to have, you know, a decimal answer. But if I want to deal with whole numbers, let me go ahead and multiply again, or multiply this original one by 100 and do 100x equals 16 with the 6 repeating. So that way these are going to subtract off, the whole decimal part is going to subtract off. It's going to be easier to work with. So I'm going to use these two. And that just is starting it off, and I'm solving for x. I'm just creating these two problems where my repeating part is right after the decimal, and I have two values with the same repeating part right after the decimal. Makes it easier to work with. So now I'll do the same thing, 100x minus 10x. I'm subtracting the two equations, bigger value minus the smaller value. Just, you could do it the other way, but this is easier. Okay. This is going to be 90x, and then 16 minus 1 is 15. And then do your division. Both divisible by 3. Both divisible by 15, excuse me. Okay, and we get 1/6, which you may have recognized that from the beginning. Okay, so there you go. Let's do one more, slightly different, and then hopefully you can apply this to ones that are even different from the 4 that I'm showing. So this is going to have a whole number part. It's going to be similar to this in that, you know, you've got a digit after the decimal that's not repeating, and then the repeating part, okay, now is 2 digits. Okay, so let me show you how I do with this. I would once again let x equal just the decimal part. Not just the repeating part, you got to keep the whole decimal part so that, because you can split apart, okay? All right, I guess you could do 0.35 repeating, but that'd probably make your life a little harder. All right, let's do the same thing here. Let's get that repeating part right after the decimal so that then I can not have decimals in this step right here, okay? All right, and then I'm going to create another equation where I have the same repeating part, okay, right after the decimal. So I need to multiply this equation by 100, which is going to create a 1,000 over here. All right. So then we subtract the two equations. Excuse me, I dropped my x here. It needs to be there. All right. Put this right here. Okay, so this becomes 990x over here, and then this subtraction we get 233. And then we do our division. All right, and then we'll add in our whole number part. This doesn't reduce. And change it to an improper fraction. Just adding 12. All right. And that is that one. Okay, so hopefully this was helpful, showing you several different examples of how to handle this, and hopefully you can apply it to another format of something that you may see in homework or quiz. Okay, thanks for watching. Bye.